All right, guys. So one thing that I did not mention last week when we were looking at the equilibrium expression or equilibrium constant, we were dealing with K or KC, which is the K using concentrations. But there is also a KP value that we can deal with. So looking at how they compare, how you would solve for each of them. Here we have the reaction of hydrogen and nitrogen producing ammonia. For K, excuse me, for KC, which is what we did last week, we said it's always those products over reactants. And we did use brackets for concentrations. So that was the ammonia. And remember, there's a coefficient of 2, so that would be squared, divided by the hydrogen. That would be cubed because there's a coefficient of 3. And that would be multiplied by the nitrogen concentration with no exponent. So that was what we were using as the expression for KC, using concentration. With KP, one thing to note is that brackets signify a concentration. So pressures are not measured in concentrations. They are measured in atmospheres. So whenever we are dealing with pressures, there are not brackets. We will use parentheses, and you'll see this on your reference sheet. So it's still going to be a similar expression, but we're dealing with the individual pressures of the products and pressures of the reactants instead of the concentrations. So on top, we will have the pressure of ammonia squared divided by the pressure of hydrogen cubed times the pressure of nitrogen. So notice that we use parentheses when we're talking about pressures, and all of our variables are designated as P regarding the pressure of whatever that substance is. All other rules still apply, that if there is a coefficient, it now becomes the exponent. So let's flip over, and I'm going to look at an example. It's experiment 3 in your graphing equilibrium activity, so you can see how this applies. Morning. All right, guys, so here is experiment C on your graphing equilibrium activity, and we're not going to go through the whole thing, but it does tell us that at high temperatures, we have the nitrosyl chloride, which is the NaCl, decomposes as shown with the reaction below. I want to go down to part 3 of this. Excuse me. And what I'm going to do is I'm going to rewrite the equation. So 2NOCl making 2NO and then Cl2. Just that way we don't have to scroll back and forth. All right, so that is the reaction that was before. Here it wants us to set up the Kp expression for the reaction and then calculate it. So I just want to go over the setup with you guys. You'll be able to calculate it as you're working through. So remember, Kp is specifically talking about pressures. So remember, with pressures, there are no brackets, only parentheses. So for our Kp, we're going to have the pressure of our products on top. So we're going to have the pressure of NO. That will be squared times the pressure of chlorine. That is not going to have an exponent. And that will be divided by the pressure of the nitrosyl chloride, the NaCl, and that will be squared. So make sure that you are using brackets if it is a concentration, and using the parentheses and the P's if it is a pressure. So hopefully that will help you get through the rest of this activity.